Good afternoon, everyone. I'm Pubudu from APNIC, and even if I have been here for 8 years, this is the first time I'm attending a APAN event, and I'm joining you all from Brisbane. Today, I'll be presenting to you about historical IPv4 resources and RPKI, and together with Awal, I will talk about the historical resources part first, and then Awal will take over to talk about the RPKI later on. Let's look at the agenda. For those who are new, I will introduce APNIC very briefly, and moving on to our main topic, historical addresses, and what challenges the community and APNIC are facing in managing these historical resources and what impacts that it has on the community. Policies and the recent Executive Council resolutions to overcome some of these challenges, and action items that APNIC plans to take as per the EC resolutions. And finally, some of the APNIC benefits that all of you can enjoy. About APNIC, I will keep it as brief as possible because I'm pretty sure that most of you have heard about APNIC. But for those who are new, APNIC is the regional internet registry for Asia Pacific out of 5 regional internet registries in the world. And we cover about 56 economies in the region, starting from Pacific Islands in the east all the way to Afghanistan. And APNIC is a non-for-profit member-based organization with currently about 8,500 members, and there's only one office, and that is based in Brisbane, Australia. And for those who are interested to know more about APNIC, there's a URL at the bottom of the slide. You can have a look. Okay, let's move on to the main topic. What are historical resources? So IPv4, as all of you might know, was available for use long before the establishment of the RIR structure. That means these IP addresses were given to organizations in the early days through different registries like Internic, Srinic, AUNIC in Australia, and so on. Therefore, they did not have any formal agreement with APNIC or other functional RIRs at the moment. And most of these historical resource custodians happens to be large corporations and educational institutes like universities, who got large chunks of IP address space when it was available in advance, way before the final / policies came into life. And some of these prefixes were given to projects, departments under those respective names and did not have a legal entity behind them, or the legal entity was not even represented in the details. Therefore, there's not much consistency in the details that we have compared to what we have now with the current registrations. Regardless of APNIC's policy changes, procedural changes, or fee changes, these early registrations were honored and they were not affected too much. And the early registered custodians were able to use them as they wish with the details that were recorded at that time. So this brings us to some of the challenges that we face. Since it was not mandatory for these custodians to open an APNIC account, some of them did not. That means they did not have any means of updating these details associated with the prefixes, leading to inaccurate, outdated registration details or complete lack of it. And some of the custodian organizations have gone through mergers, deregistrations, name changes, making it very difficult to establish their ownership of who they used to be. Therefore, what you see in the WHOIS database related to these historical IP prefixes may have been obsolete. And there's a security concern as well. These early registrations usually had their own maintainers. And if a hacker or someone managed to get access to these maintainers, they could pretend to be the legitimate owner and then get hold of these IP addresses. And there's a problem to the internet community as well. at APNIC Help Desk, we often get complaints from the community regarding network abuse, like DDoS attacks or spamming, etc. And in some cases, they happen to originate from some of these historical unclaimed addresses, which means we don't have any accurate contact details to reach to them. Therefore, taking action regarding these abuse behavior has been very inefficient. To address some of these challenges, if we go back to a few years, in 2004, Prop 018 was implemented, and it made it kind of difficult for the hackers to take control over unclaimed historical resources. This was achieved by putting APNIC's maintainer to protect them. Therefore, if anyone who wished to update these resources, they had to first come to APNIC and then prove their authority to take control of them or prove their ownership, thus preventing hackers from altering the WHOIS details. The legit historical custodians were allowed to open a non-member account by paying an annual fee of $200, regardless of the prefix size, and the accounts were called historical resource maintenance accounts. Once they open an APNIC account, they were able to access My APNIC, do their updates by themselves, and create WHOIS records such as IRR records, reverse DNS, and etc. However, RPKI services were not extended to these accounts. The main reason in 2004 was that RPKI did not exist at that time. But even after APNIC first deployed RPKI in 2010, it was not available to historical maintenance accounts, because until quite recently, RPKI did not get much traction and there was no real demand or usage. Moving forward to the current times, in 2021 May, Executive Council of APNIC decided that RPKI should be made available to all historical resource accounts. ROA is in full flow now, and quite a few ISPs are now doing ROA validations, impacting the routability of those historical resources. In addition, ROA helps secure the internet for everyone, not just for those who create it. And the community, from the community also, there was strong voice that if the infrastructure is there, why not extend these facilities to historical resource holders as well, which led to this easy resolution. The second part of the resolution is to get all these unclaimed resources under APNIC accounts. As part of this resolution, the custodians who have not yet claimed their resources are required to set up membership accounts or a non-member account by the 1st of January 2023 if they were to receive registry services continuously. And failing to do so, what will happen is these resources will go into a reserved state, and the WHOIS details, the historical resource details will be taken off the public WHOIS database. This is quite important. Therefore, if your organizations are using historical resources, please make sure that they are claimed. And if you're not sure, please reach out to Help Desk to verify this. So the action items from APNIC, as per our most recent records, there are about 7.2 million IPv4 addresses belonging to roughly 3,500 custodians, which are unclaimed. This year, we are launching a project in order to address this. We will try our best to reach out to these historical custodians with contact information available in WHOIS database, website, any known contacts, and any other means that is available to us. This is not an easy task, as I mentioned before. The contact information available on the WHOIS database are more than 30, 40 years old sometimes. And the emails have changed, phone numbers have changed, contact persons have moved on to other jobs, retired, companies no longer exist, and so on and so forth. So if you happen to get an email from APNIC regarding historical resources, please don't delete it. We need your help in finding the original custodians or inheritors of them. And if you believe your organization has historical resources, but have no idea how to claim it, please contact Help Desk again. We'll be able to help you. And some of these resources are not being routed for years. So we expect that the original custodians who are not really using them will allow APNIC to recycle them and delegate them to, so that we can delegate them to people who really need it, putting this scarce IPv4 resource into good use. So these are some of the many benefits that anyone can get, not just historical resource custodians if they join APNIC. This is quite generic information. So the IP addresses you get would be portable resources. That means you can take IPs with you even if you switch your ISP providers, and you can do multi-homing for robust connectivity and so on. And access to My APNIC is available to all APNIC account holders. So you can create your route objects, domain objects, create ROAS yourself, which means you have more control over your network and your IP addresses. Free or discounted training is available for APNIC members, and technical assistance for specific organization requirements are also available to APNIC members. Complimentary conference tickets are available at APNIC events, and you can get direct assistance from APNIC help desk regarding any inquiry about membership or historical any resource actually. Last slide. So this is actually a very broad breakdown of where our members are coming from. No surprises, hosting centers and internet service providers make more than half of them. But in the recent years, we can see, or we have seen that banking, financial institutions, academic education research like BD-REN, Learn, PERN are becoming our members. This shows that a wide variety of industries are benefiting from becoming APNIC members. Therefore, don't think that your organizations cannot benefit from APNIC membership because you are not an ISP or a hosting provider. So that actually brings end to my presentation. So before I hand over to Aval, I'm happy to take if there are any questions. Anything on chat? Okay, looks like no questions. So, Aval, are you ready? Can I stop sharing my screen so you can start?
Yes.
Okay. Thanks a lot.
Thank you, Prabhudu. Let me share the screen. I hope it's visible.
Yep.
Yes, so thank you so much, Prabhudu. And my name is Awal, and I am going to talk about the internet routing security with RPKI. And this has been a talk us for last couple of years because RPKI, ROA, these are some of the most important topics in the networking world, in the internet routing world for last couple of years. And why is it? Because there has been, some unexpected incidents happening every now and then in the routing world that has severe impact in the network operations. And I believe many of you here has the idea of how the global routing works. And one of the most important protocol that operates the global routing is called the Border Gateway Protocol, or BGP. And just to simplify the concept of BGP, here is a simple topology that would explain how the prefixes are propagating through the networks and reach to the other side, or reach to all the networks in the and BGP very vital role in propagating the prefix information. So what happens is, here is an example of a prefix which is 61.45. Let me try to enable the annotation. Yeah. So this is a prefix 61.45.248.0/22, and it is the owner or the announcer of this prefix is AS135533. Now this AS is announcing the prefix to its neighbor via BGP, and BGP helps network operators further propagate the prefixes to their neighbors, and so on and so forth. And using that process, let's say that comes to your router. So your router is having a prefix from the neighbor via BGP, and the prefix is 61.45.248/22, and it traverses these AS numbers to come to your router. So this is kind of the simplified version of the operation. And now let's think about there is another prefix which is a /24, and it's a subnet of the /22 here. Now another is 135540 is now announcing this subnet or a smaller prefix, and BGP is happy to carry the prefix to the neighbor, and the neighbor announcing it to you. Now router sees two prefixes. One is a parent, which is a /22. The other one is the subnet or child of that bigger subnet, which is a /24. So how the routing will work here? And this is the basic principle of routing operations, that the router will choose the more specific path or more specific subnet to reach to that particular destination. And in that case, any IP destination that is part of this prefix, which is also part of that bigger prefix, but the router will choose the path which is more specific. In our case, it's a /24 because it's a smaller subnet, and the router will take that path to the destination. Now think about a situation where this AS number is the legitimate owner of that prefix, and this AS number is a bad guy, and they're not the legitimate owner, and they tries to hijack of the traffic from the actual destination. Now this situation seems like hypothetical, but it's not. It's real. It happens in routing world every now and then. So what will happen is the attacker would actually successful here to reroute your traffic, which is supposed to go this direction to your network, but now it will actually take this path to come to a wrong place to find the destination. And this way the BGP hijacking is possible. Here is another way that, because the routing table behavior or routing decision takes based on some certain criteria. Now second criteria, or here we are, the most common criteria is the AS path. Now remember, I was saying that your router is going to receive that prefix, and you will what are the AS numbers that prefix took to come to your network. So this is the AS traverse come. Like I was saying that in this case, the subnet size is same, but the AS path is different, and the router is gonna choose the smaller AS path compared to the bigger AS path, because router thinks it's far away compared to the path that has a smaller number of ASs in the AS path. So the traffic will actually go to this direction, even though the prefix size this time is same. So this can also be used by this method, or this routing behavior can also be exploited by the attackers to reroute or hijack traffic from the actual destination. So that's the two methods. Like I say, announcement can be done. If it is a most specific announcement, then your traffic is gonna take the path compared to the less specific announcement, or maybe longer subnet size. The other method, like I explained, would be probably the same subnet, not the most specific, same subnet, but you are announcing it, and it is not your prefix, probably by mistake or probably intentionally. Someone is announcing the prefix to reroute some of the traffic for some destinations. That's used for BGP hijacks. Now, whether this is something that we need to bother about, or why actually we should bother. If you were a network engineer, you would probably don't want your routing to break. You probably don't want your customer routes to disappear from internet. They would probably call you that I'm having some trouble using your network. Or if you don't want your name on the headlines, then probably you should bother about it, right? So some of the headlines that happened before actually caught the attention of the network engineers and users as well. So very recently, in April 2021, this AS54410, which is actually an Indian network operator, they announced about 30,000 prefixes that brings that affected 164 countries and about 4,000 AS numbers for about 1.5 hours. So what happened is these they leaked some more specific prefixes of other network operators, and when they were doing that, many of the prefixes do not have ROAs. So what is a ROA? We'll come to that later, but it's kind of a digital object that can prove who is the legitimate, who has the authorization to announce the prefix using their AS numbers. But even worse, when a AS leaks routes or hijack prefixes, it actually doesn't have much impact if their upstreams or their peers can block it and can identify that this is not a legitimate announcement. But in this case, it actually means some of the other peers or providers, they also further announce those to the internet. Another incident happened in Myanmar in February 2020 year, where during the military invasion in they ordered network operators to block some social medias. So one of the AS136168, they announced Twitter prefix with a more specific announcement. In this case, it's a /24. Now, this prefix travel via their providers, transits, and peers to the internet. And for many of the users, Twitter become unreachable. The good thing is that many operators already filtered that because they probably had some kind of prefix filters or AS filters in their network. But the bad thing is that there are a couple of peers, for example, these 6 peers, they accepted the announcement and further propagated to the internet. That means they didn't have the filters or kind of routing security mechanism for this particular customer. And also, Twitter doesn't have ROA for that particular prefix. If they have ROA, what would happen is that larger operators, they already started origin validation based on ROA. So probably in that case, the impact would be minimized. This is an incident from September 2020 when Telstra announced about 500 prefixes, which includes SAP, ProtonMail, and it has about 3 hours due to their wrong router configuration. And another incident from July 2020, which is because of BGP optimizers. So the Telex, which is an operator in the US, they leaked about 100 prefixes mostly from the North American AS numbers, and it has impact for about 2 hours. So what happened is that they announced it, and Telia, one of the largest provider, they didn't filter that. They actually further propagated it. So it's kind of some shared responsibility here. Similar incident, this time much severe. It is during the April 2020 when a Russian operator, Rostelecom, they hijacked about 8,000 prefixes from all the different very crucial content providers here: Facebook, Cloudflare, AWS, Google, DigitalOcean, Akamai. They had been unreachable for several for about an hour. And what happened is that Rostelecom announced it to Cogent, it to level 3, and they each of them actually they didn't do the validation, whether it is RPKI based validation or prefix or field S path based validation, but it actually got successfully announced those leaked prefixes to the internet. This time, Cloudflare in June 2019 got severely affected, and about 15% of their global traffic got blackholed because of this wrong announcement by the BGP optimizers. So the Cloudflare announced their /20 to their upstream. Their upstream announced it to one of their customers, DQE. And DQE used a BGP optimizer that split the /20 into 2/21, which is more specific, and announced further to their upstreams. And that means traffic goes to the this smaller network operator doesn't have even that big bandwidth to accommodate that huge amount of traffic to Cloudflare, and that causes severe impact in the internet world. Similar incident, November 2018, Google prefix was leaked by some operators in Nigeria, and also blocked at the gateway of some operators in China as well as in Russia. Google prefix has leaked by one of the operators here, main one, which is in Nigeria, and they subsequently participate in the severe impact of the Google services. This is one of the incidents from April 2018, and this incident goes on, and it requires a long time to explain each of them. So I'm just going through this quickly. Amazon's Route 53 prefix that got hijacked by a network AS10279, and they had this more specific announcements of Amazon's /21 prefix into /24s. And these prefixes actually rerouted to answer some illegitimate server for a DNS queries. And it turns out that my Ether wallet is the domain that's getting answer from that hijacked Route 53, and that the traffic goes rerouted to some kind of man in the middle attack. So that's the server where the attacker was listening to the username and password. Probably they're collecting those data for some malicious actions. And Google also announced some prefixes of entities in Japan in August 2017 that brings their traffic rerouted via US. And as you can see, before route leak, traffic from Japan resides within Japan. But after the leak, the traffic from Japan goes to US, to Canada, and then come to Japan. And similar thing happened from European routes. It's not within Europe, it goes to New York, Chicago, and then comes back to their network. And this is the famous one in February 2018, even though it's long before those incidents, but still people remember that TCL have caused kind of 2 hours of impact of Google prefixes globally. So Google services were severely affected during that time. So why do we see this every now and then? Why almost every day there are some routing incidents? Because there is no single authority in charge to take care of the routing hygiene. It's their responsibility to take care of the routing hygiene. When we are a network operator, we are maintaining our network. We need to maintain a high routing hygiene within our network, and every single network operator needs to do that. And that is the reason why there are some issues, because probably one of the network operators are doing something intentionally or unintentionally, they're causing some outage in the internet. So there is no single authority model, and there is no reference point to identify what's right or what's wrong in the routing. And another reason is that routing works by rumor. That means the routers, they believes the neighbors. So whatever neighbors tell them, they accept that, or whatever the router has in its routing table, it tries to send this information to the neighbors. So routers understand or thinks that their neighbors are honest and whatever they are sending are correct. But how do you actually understand, or how can you actually validate what is the right announcement, or the prefix that is announced by a AS number, whether that AS is the legitimate owner of that prefix or has the right to announce that prefix? There are other reasons, such as the routing table is actually the routing table is built by the local view of the router itself. It cannot compare its own routing table with someone else's routing table and cannot decide that my view of the routing is actually not right. Maybe the other routers, it has a better routing view, because that is not the way how routing works. And routing works in reverse to the routing, the traffic flow works in reverse of the routing advertisement. So the outbound advertisement affects the inbound traffic, and inbound advertisement affects the outbound traffic. So anyway, in BGP announcement, if your advertisement is wrong, your traffic is not gonna understand that. Your traffic is just gonna take the path that the routing table has as the best path. And there is no evil bit or E bit enabled in a bad routing prefix or bad prefix. So the bad prefix itself cannot identify it as bad, even though this RFC, which is a funny one, this RFC says we should have, actually we should have, but there's no way of doing it at this point, right? So how we identify that this is a good routing announcement and we should accept it, and this is a bad routing announcement and we shouldn't accept that? And we should worry about it, whether we should care about it. Yes, we should care about it, but because it's kind of shared responsibility. If someone does something wrong, it can affect my network or my customers' traffic. And that's why we need to worry, even though we don't directly related in terms of network operations, but their actions affect us. So that's why we need to worry about it. So what can be done? What can be done by the network operators? There is no kind of dispute that we should implement good routing hygiene in the network. And the most important recommendation here is that try to filter the good prefixes, filter the good AS numbers, and make sure that your routing table has all the prefixes that are good, seemingly good. How can we do that? We configure prefix list, filter, or we can do kind of some policies that checks prefixes. If they're they are allowed for some certain conditions, then only will accept that, some kind of hygiene in terms of prefix filtering. What is the current practice? The current practice in many of the places in the world is that when you receive a request from your customer to advertise or to allow a prefix to advertise to internet, what we do is check whether they have the kind of authority to do that. How we do that? We have a couple of methods to check that. And then if they pass the validation, or if we find that they have the authority, then we can allow them in the filters, inbound or outbound, and then based on that, BGP can take actions. So for the letter of authority or LOA check, we have kind of manual whiz check here, or we can check the letter of authority, which is the letter that mentions that this AS number is authorized to announce this prefix. And we can also do some automation here using some IRR tool sets written in RPSL, which is routing policy specification language. So this is the manual whiz check. So there is a protocol called whiz, and you can write this, you can use this tool whiz and then mention the repository that has this data. For example, in this case, we are looking whiz.apnic.net for a prefix and its related information using the whiz protocol, and it will show us what is the prefix and who is the owner of that prefix, the location, and all the relevant information in this object. And we can also get the routing related object here, which is called route object for IPv4, and IPv6 it's a route 6 object, and that mentions that this prefix is okay if it is announced via this AS number 131107, something like this. So this is the authorized AS that can advertise this prefix. So this is the information we can get from the manual whiz. And this is a letter of authority. This is a letter that mentions that this AS number can announce this prefix, something like this. And like I said, the other method, it could be some kind of, little bit of automation. Based on the information that we put in the Internet Routing Registries database, such as the route information, we can also mention, as you can see on the right side, we can also mention some policies there, such as we can say that if we receive prefixes from this AS number, we'll set local preference to some values, or if this is my neighbor, I'm going to announce these prefixes or the AS numbers that has the prefixes are going to be announced to this neighbor, something like this. And this is maintained by the maintainer of that particular account. Using that IRR information, we can do some kind of automation. We can use some automation tools to create the filter list or prefix lists. In this case, in this example, we are showing this tool which is called BGPQ3. That's a package in your in a Linux distribution or Unix distributions, which you can install, and then you can use the command syntax to create automated prefix list on different kind of for different kind of operating systems, such as for Bird or for Juniper, Cisco, and many different other OSs. Here is an example for Juniper. As you can see, we are querying APNIC whiz database or IRR database as the source to create a prefix list with this name for these AS numbers. So this AS number is authorized to use these prefixes. So it creates a prefix list and allows only that prefixes, that these are the legitimate prefixes allowed for this AS to be used. And on the right side, you see BGPQ3 can be used create AS path filter list, looking at the AuthNum object and AS set objects to subsequently identify its customer AS numbers, so that the upstream provider or transit provider can put an inbound filter list for that certain AS set. So that can be used as well. But with these tools and techniques, there are problems as well with this IRR model, because there is no single authority here. We have several databases there, and it is hard to identify or hard whether some certain entry is genuine and correct or not. there could be different entries, such as, there could be two versions of it. One could be recent, the other one could be long ago. There could be, then in that case, how you understand which one is the right one? There could be entries, different entries for same prefixes in different RRs. Then how you will understand which one is the right one? And there could be route that is not listed in any errors, whether is it invalid or is it just missing data or what? How can you determine that? And in terms of scalability, how can you put a filter list based on the IRR for the full routing table? And that's quite impossible to do that, right? Because it's the whole routing table or global routing table that now you're gonna check, and it's not possible. So these are the problems. And if you are really doing that, if you are automating the filter lists or filters using the IRR filters with the automated tools, then you need to make sure that you are collecting data from a source that is reliable. So mention for BGPQ3 using -s, which is the source. In our case, in the previous example, we have shown you that we are checking the APNIC IRR database to create the filter list. And for the RPSL RT config, you can use -. For that, this way you can actually understand or rely on a database that is more reliable to you, or that you find more reliable. You can use that as a source. But is there any other way? Is there any other better way of identifying which prefixes are good? Yes, actually, we can do that. We can use digital signature to identify the legitimate or authorized AS number to announce a certain prefix. And how can we do that? We can use the PKI or public key infrastructure that to convey the authority to use. And we can have the private key to sign the authority and the public key to validate the authority. And there should be the PKI to carry all this cryptographic information and the keys. So once we have the private key and public key, the resource holder of the resources can use this private key to authorize their resources, right? And then whoever is validating can use the resource holder's public key to the signature. And how do we build the chain of trust, right? So we can simply follow the resource allocation hierarchy to build the chain of trust. For example, the RIRs, they distribute addresses to ISPs, or maybe via the national internet registries, ISPs, through the ISPs to the end resource holders or end users. So this is the resource allocation hierarchy, and we can utilize this model to create the chain of trust in terms of PKI. So the RIRs can have their self-signed root certificate. Here in our case, we are showing that APNIC has its root certificate, self-signed, and then it can cross-sign or validate the NIR's signature, signed signature, and it can also, the NIR can cross-sign the customers or ISP's signature. This way, the signature chain of trust is going to be built. What we are going to do is we are actually going to create a digitally signed object, which is also known as route origin authorization or ROA. And a ROA is a combination of three information. Basically, it's a prefix with a max length value and the origin AS number. And with these three information, we are going to create the ROA once it is signed by the resource holders. So for a certain prefix, there can be multiple ROAs. right? Now, once we have the ROA, RPKI can authoritatively prove who is the legitimate owner of this prefix and which AS has the permission to announce the resources in the BGP or in the routing table. And this eventually can help prevent route hijacks, misorigination, and misconfiguration. So whenever there is a prefix announced to the internet, and the router that is able to check the ROA can actually look at the, let me go to the previous slide, can look at this information and the information that is received by the router by its neighbor, and then it can figure out that this prefix has been announced by a S number. If the S number matches with this one, then it's a legitimate announcement. Otherwise, it's a invalid announcement. So once you have this, you can actually have some sort of filtering techniques, automated filtering techniques to BGP. Now, RPKI, in order to achieve this this kind of model, we have two components. One is called the issuing party, which is usually the internet registries who issues the certificate to the resource holders, and they are responsible to publish the ROAs via their repositories. So here, for example, if you have an APNIC account, you can go to the My APNIC portal, and then from there, you can create your digitally signed object, which is ROA, using RPKI engine, and then that resource or that ROA is gonna be stored and published in the repository, which is rpki.apnic.net, and all the members' ROAs are there in the repositories. And similarly, other RIAs such as RIPE NCC, Marine, and all the other 4 RIAs can have their repos. Along with the NIR's repos, all the reports are gonna be collected. All the information in the repos are gonna be collected by some applications called the relying party software. So that's the second component of RPKI. Now, let's say we are running a validator, which is a relying party software, and the validator is pre-populated with information of this location for these repos, and all the repos will be contacted by this validator to face the data and collect all the rows and do this cryptographic check of whether this is kind of the signature along with the trust anchors certificates, and then they will build the chain of trust and identify something called this validated cache. So that is stored here locally in this kind of server. And then your router can talk to that server and can actually check for each of the announcement. Let me draw this diagram here quickly. If you have your router here and your validator running here, it already collected information from different repos and populated its validated cache with the VRPs, and these can be downloaded by the router locally. Then if any BGP speaking neighbor send a BGP announcement with some certain prefix along with the AS path, now it has the prefix, max length, and AS path already in the VRP table. Now it can actually cross-check whether this announcement is authorized, comparing with the VRPs here. So that way it can mark a prefix either valid or invalid or not found. So if the prefix and its prefix length and the AS path and the origin AS has a match in the database, that means it's a valid prefix. And if it is found there, but the information is not a match, it's an invalid prefix. And if the information is not there in the VRP table, that means the ROA is probably not created yet. So it's let's say not found to the router. So here is an example. Let's say we have a ROA created with this AS number, this for this prefix and for this max length. And let me talk about this max length. So this max length is actually related to this prefix. So if you have a prefix which is a /16 and you would like to cover a ROA for the prefix up to /18, which means for a single /16 we are gonna get 217, and each of the 17 is gonna get. So now with this /16 and max length /18, we are actually covering one prefix, 2, 3, 4, 5, 6, 7 prefixes within one row. We are going to actually cover all these 7 prefixes. So that's the purpose of mentioning the max length. It's just a range of prefixes that you are gonna cover within this row. So if you have this row now, and now your router, so let's say this is your router and it already gets this information from the validator, and now there is a BGP announcement coming from the neighbor to this router R1. Now it's gonna check with this row whether this is valid or not. Let's see if the origin is of a prefix 10.0.0.0/16 is coming to the router R1, it is now gonna check this with this row, and the S is okay and the prefix is okay. So that's gonna be a valid prefix, right? Now, this S number is still the same. Now we have a prefix that is a /17 and which covers by this prefix and with this max length combination. So that's also a valid prefix, right? But now the S number is different, even though the prefix covers by the row, but the S number is not a match. That means it's an invalid prefix. And this time the S number is same. The prefix subnet size is not within the max length value. It's beyond the range. /24 is beyond the range. That's why it's called max length invalid, right? The prefix is invalid because it's a wrong origin S. This one is invalid because it's a max length invalid. And the last one, here is an example. The S number is different and the prefix is not covered by this row. It's not within this range and not even its subnet. So that's why it's called not found, because this row is probably not yet created, right? Now, once your router can identify whether it is a valid, invalid, or not found in terms of RPKI validation, what you can do is you can take different actions. You can tag a valid prefix with some certain community value, and you can tell your customers or your peers that if you see some kind of I think some background noise there. Please turn off your microphone. If you have a valid prefix, what you can do is you can mark it with a community value, and you can publish that information for your customers that if you see this community, that prefix is a valid prefix. If you see this community, it's a not found. And if it is some other community that is mentioned here, it's a invalid prefix. So you probably can help your customer take action based on this community. Even probably they're not running the validation, but they can understand, their router can understand community, and this community tag can help them identify what is the validation state of the route. What else we can do? We can actually reduce the preference value based on this PKI states. For example, valid prefixes gets higher preference, not found lower than that, and invalid gets lowest preference. Or many operators are choosing to drop invalids. So if you that dropping invalids is an option for you, you can definitely drop that. That means you are actually dropping about 6K of IPv4 invalid prefixes and 3K of IPv6 invalid prefixes. Now, there could be some other situations. For example, this router is validating, and let's say there is a prefix announcement coming from its neighbor, which is R2 coming to R1. And let's say there is a malicious network operator here, the rogue guy, pretending that it has the same AS number, which is probably the customer AS number here. So that prefix is coming to your router with the AS number, which is same as this prefix. And this is called validated hijack. And how we can protect that? We probably need to check the AS path as well, not just the origin. So the AS path validation is under discussion in IETF, and there had been some very promising proposals at this moment, and probably we'll have some kind of solution for that. We can actually use RPKI certificates to do this path validation, right? And it's going to happen per prefix. But let's see. Let's wait for the most optimized and solution for AS path validation. For the RTR session, so RTR session means from your router to the validator server. That's called the RPKI to router session. This session can be with this plain without any security configurations, if you run it locally within your infrastructure, within secure environment, or you can actually apply some other security mechanisms such as authentication, tunneling, or TCP authentication options, and so on. There are some considerations that you need to think of in terms of deploying validators. So when your RTR session goes down due to some error, for example, the validator stopped working, or this links goes down, or this communication fails, depending on the operating systems that you are running in your router, it can have different behavior. For example, if you see that Juniper, if it goes down, that is for about an hour. For Cisco, it's kind of a couple of minutes, and maybe the RFC recommends that it should be about 10 minutes. So it's configurable. You can configure that. The defaults, when this link goes down, RTS session is down. That means your router is not getting any fresh BRPs from the validator. That means the router is now gonna receive all the invalid routes from the neighbor as well and identify it as not found, because the validation state is not possible to check, right? So that's falling to not found. That means invalid routes are treated as not found now, right? So the recommendation here is you run at least 2 validators, because if you're on one of the validators goes down, you still have another validator talking to your router, and it still can identify the invalid routes or valid routes based on RPKI validation, right? Now, if you are dropping invalids, remember, if you have default route, the invalid routes that are actually expressing some kind of destination to you, those destinations are still reachable via your default router, right? So if you are dropping invalid, you probably need to drop default route as well, and also receive the full global routing table. Other dropping invalid probably would not make good for you, but what you can do is when you supply these routes to your customers, announce them to your customer, probably drop invalid, you are not gonna get those invalid routes. That's it, but the traffic is still going using the default route. For the ROA consider this max length value. For if you have a /21 and you are setting a max length /24, that means you are covering quite a good number, about 15 routes within this range. And if you really do not announce all these prefixes, you don't need to create that many, you don't need to cover that many prefixes within this. That's going to be exposed a chance for to take, which is called the validated hijack, right? So try to cover your prefixes, make sure that you don't miss out any of your BGP announcements. At the same time, consider creating minimal row. That means the amount of BGP announcements you are going to make sure only those prefixes are covered by the ROA, not the additional prefixes if it is not really necessary. There is this concept called S0. So it is called this negative attestation. By that, we mean there could be prefixes that will never be announced by any ASS. For example, if you are running an IXP, let's say this prefix is supposed to be not available in the global routing table. So, or probably some prefixes that are for a different purpose, some reserved prefixes that shouldn't be announced by any public AS numbers in the global routing table. So in that cases, or have some certain infrastructure route that you don't want to advertise to the global internet. So what you can do is you can create ROA using AS0 to tell that these prefixes are not supposed to be announced or not supposed to be visible in the global routing table, something like this. But if you have a ROA created using AS0, and for the same prefix, if you have another ROA with another AS number or valid AS number, then that ROA is going to override ROA created with AS0, right? And APNIC supports that. And there is a policy which was initially a proposal 132, and now it's a policy. So it says that unallocated address space that is in custody of APNIC that is supposed to allocate to the customers in future, those prefixes should be having ROAs using AS0. And APNIC started implemented that in September 2020, and it has a different TAL or trust anchor locator. If you ever see the validator that is configured, there are TALs, and APNIC has this as operational TAL that is for the ROAs, that's for publicly used by the repository, and there is a separate for AS0 ROAs. And it's kind of opt-in. If you really want that, you need to manually download it or accept it explicitly. Otherwise, you just get the default TAL that we have. The process for that is that if you configure any prefix with AS0, it's gonna be taking some time. You need to wait for the cron job to be done to add it to the repository. But if you remove that, it is very fast to be removed, because you probably need to, previously you created created a ROA with AS0, and now you need to really use that prefix with a public AS number to announce it in BGP. It should be fast, right? Otherwise, you need to wait for that for like longer time, and you may not have that much time. So that's why it is fast. It's gonna be within 5 minutes once you withdraw that. So the summary, let me see how we are doing in terms of time. Yeah, we have some time for question and answers as well. So let me summarize what we have just discussed for my. So the basic BGP hygiene should be in place if you are a network operator. Check this RFC, that is filtering techniques and filtering recommendations. And this is the RFC that says the default behavior for BGP neighbors, it should reject unless you explicitly accept the BGP routes, right? So let's say when you bring up your BGP session with a neighbor, many routing, many equipment, many router manufacturer by default accept whatever the neighbor says, and by default announce whatever you have in your BGP table. And that means, for example, if you want to configure some filters, and by this time you already extend your routing table with your neighbor, then now if you filter, if you apply the filter, it's not gonna take immediate effect because you already have those routes in your routing table and you already announced your routes to the neighbors. So that's the RFC. Let's take a look at these at some point. And the filtering best practices. Please filter prefixes for your customers based on this filter list specific for them. So what we do is a router here, and if I have a customer connected with me, day one, before configuring BGP, what we can do is we can ask for their information such as their AS number, their prefixes. We can check the whois and stars, and then we can actually configure a prefix list even before bringing up their BGP session. Or we can use some automation tool to do that. And based on our discussion, what we can do is we can do validation, which is even better considering the recent incidents. What we can do, what else we can do? We can do AS path filter list. We can set some AS path limit. So what is the maximum number of ASs you can have in a prefix, something like this. And we can do this IRR based automated prefix creation or prefix list or filter list creation and apply that to the BGP neighbors. Filter whatever you receive from your upstreams. There are bogon routes. There could be routes that are not supposed to be in the global routing table. So you need to find some way to apply the BGP filtering techniques for your upstream providers. Create ROAs for your prefixes if you have. So if you have prefixes from APNIC, you definitely have your My APNIC access, and then go there. If you have the TOTP or two-factor authentication enabled, then you can use that to enable your RPKI engine there, and then create ROAs for your prefixes for your IPv4 as well as for your IPv6 prefixes. And it's very simple with this current portal. So you will find it very easy to do. And if you have any question related to how to create ROAs and stuff, please reach out to us, any of us, our colleagues. They will be very happy to do that. And I'll be around for different, talks and different training programs as well. If you would like to talk to me about the ROA creation or validator setup or RPKI based validation, I'd be more than happy to talk about it. And once you have the ROA you created to save or to secure your routes not to be announced by any other AS numbers, intentionally or unintentionally, but to protect your routing infrastructure, to protect your routing, your customers' routing table, you would probably think about configuring the validation or the validation, which is I explained it, which is the validator you have. It will pull all the ROAs, the cryptographic checks, create the VRP table, hand it over to your, then the route has some reference to check for each of its BGP announcements received from the neighbor. So that's the origin validation, and based on that you can take actions. You can drop invalid, you can mark with some community, you can do manipulation, something like this. And take a look at manners.org. That's a very good industry initiative that has good resources as well, that will help you understand routing hygienes and how you can contribute, how you participate there as a community, and can help the global internet infrastructure run better. That's one of our key responsibility as a network operator. And that's it from my side. And I will stop here and would look for questions if you have.
Kubudu, are you here?
Yeah, I'm here.
Okay. In fact, I have a question because I just received a question from a friend working in NRAN, and he is asking, like if their NREN has universities as members, and some of them might be historical address holders. And of course, they know about the address blocks that they are holding. Can the NREN people check whether those universities are having contract with APNIC already? Can they do the search on WHOIS to check that?
Yeah, they can also do the check themselves if they know the registry did, like the IP prefixes. If not, they're more than welcome to come to the help desk and we can assist them.
So is there anything on the WHOIS data which can signify like the address holder is has contract with APNIC or not? Is there any tag like that?
From WHOIS database, you cannot check whether they have a contract with APNIC or not. But if they do have an APNIC account, they should have access to my APNIC and account. So I think the best way, if they're not sure, is to let us know the IP address, then we can check whether it's under a contract or is it still yet to be claimed.
Thank you. This is, of course, also applies to other NRENs. Like if you are running the NRENs, if you have members which may need your help, then maybe you can contact APNIC, to help check the information. Thank you, Pubudu.
Yep.
Any questions from others?
Yeah, will we see blog posts on the countdown to the 1st of January next year on how successful the identifying holders versus how many addresses will be returned, and what is, I mean, obviously APNIC doesn't know how successful this project will be, nor how large the pool will be at the end, but are there any indications on what the reclaimed addresses would be used for? Or will they just follow the new member and
Pubudu, do you know the answer?
Yeah, I think Vivek can answer that question. Just one moment.
Vivek.
Yeah, hi, Chihu, Vivek here. So this project we are doing is based on the EC's directive, which was passed last year. And the EC resolution at this stage has just asked us to remove the registration from WHOIS in the event the custodians don't claim these resources by end of this year. So at this stage, that is all we intend to do. So those who claim, we'll update the registration, they will stay in WHOIS. And then those who don't claim or we can't get in contact with, the registration will be removed on 1 Jan. The status of those blocks will be updated to reserved. So if anyone's looking at a delegated stats, these IPs which previously said delegated will now say reserved. And at this stage, there is no other plans to do anything with it. Potentially in the future, there might be a policy proposal or there could be further directives from the EC on how to address it. I hope that answers the question.
Yep, if it does.
All right, thank you.
But thank you for your question. We can certainly consider it if it's helpful to the community. Okay, is Color back? No?
Sorry, I'm here. Sorry.
Okay,
Yeah.
over to you.
Sorry, I'm just struggling to find all the buttons. So I think that if there aren't any more questions, I really just wanted to say thank you to everybody that's listened in. I hope that you found that helpful. And I think that Pubudu has provided a copy of his PowerPoint for any of you who wanted to go back and just check some of those links. Otherwise, please just feel free to email us. And if there's any more information that you think about further down the track that you'd like to get more details on, then just please let us know, and we'll be really happy to take any questions after the session. So I think that we're giving you a little bit of time back. We obviously finished a little bit quicker than we expected, and so I wish you all a very good afternoon.